A spinner is split into 6 equal parts, each a different color. The spinner is spun 10 times, and each spin is independent of the last. What is the expected value for the spinner landing on red? So there are some important words in this problem that you need to pay attention to before we start. The first one is this word here, 6 equal parts. And the second one is the fact that the spinner is spun 10 times, and then the fact that each spin is independent of the last. All of these different words together should indicate to you that this is a probability problem that involves binomial probability. Now, the reason that we want to take note of that is because when you go to find expected value on a typical probability problem, you would have to create an entire chart, right, where you have your x and you have your p of x. And in this particular case, it would be kind of crazy because if we want the expected value for the spinner landing on red, we'd have to look at no red lands, 1 red land, 2 red lands, etc., until we got all the way down to 10. We'd have to figure out each of those probabilities and then multiply them and add them up. So if it was me, I would look at that and say that's an absolutely crazy problem to do. That's going to take me forever. But if we notice that it is a binomial probability problem, it gets much easier because the formula for binomial probability, the expected value of binomial probability, is just n times p. And if you can remember that, what you're going to see is this takes about 2 seconds to figure out. So we need to know what n is in this problem. Well, n is the number of trials always in a binomial probability problem. And since the spinner is spun 10 times, we have 10 trials. So n is 10. And then p is considered to be the probability of success. In this case, success is landing on red. And if there are 6 equal parts and one of those is red, success would be 1/6. So we have n being 10 and the probability being 1/6. That's the probability of landing on one of the red segment. So our expected value is going to be 10 times 1/6, which just gives me 10/6. This, when we do the division, is approximately 1.67, which means that the expected value we will expect to land on red 1.67 times when we run this experiment. And so you can see that if you look at the problem first and notice that it's a binomial probability problem, it is very, very easy to solve.